Всем привет! Меня зовут Zarakovsky Alexander, и я руковожу практикой товарной
Hello
аналитики
everyone,
в
my
компании
name
Rubbles
is Alexander Zarakovsky. I'm the head of retail analytics for FMCG, retail and QSR in Rubbles. I am responsible for project execution in all those areas. Hello, my name is A.Zarakovsky. I'm trying to make the lives of MARS employees better. I'm involved in all the projects related to sales management, demand planning, and digital marketing. Today we will talk about AI application for promotion optimization. The whole presentation will be divided into two sections. First of all, the background, and then we will tell you about our approach to addressing this objective. Well, first of all, I need to give you a definition of a promo campaign. A promo campaign is a set of activities aimed at encouraging the purchasing activity of buyers. If we look at the statistics, the share of promotion campaigns is growing. The buyers are now start hunting for promo campaigns, both online and offline. If we look at the share of promo in FMCG, we see that this percentage is quite significant, and even though there was a certain slump, it quickly recovered.
Nearly all categories increase their volume on deal, as the chart illustrates. What's important to note here is that neither retailers nor manufacturers find it feasible to over-promote goods, because obviously that way consumers will start considering it the norm, will take it for a given, and obviously it compresses the margins of manufacturers and retailers alike. What 2020 has shown is that for the first time over a long time, the share of goods sold in promos went down despite the increase in budgets. Therefore, you will actually see here like a 7% increase, which is a very rare occurrence. What is important to any manufacturer now is how to manage their promos successfully, and machine learning can certainly play a role here. That we will cover a bit later, though. The key advantages to promo optimization at MARS are listed here. Obviously, the most important objective here is to help us deliver, at least deliver on our KPIs. But if we can maximize, say, ROI for an individual promo or the whole promo calendar, we won't complain. And this is true for our objectives, but actually the same applies to our joint programs with the retailers. After all, they are our partners. Another important factor for the manufacturer is the ability to increase the accuracy of our forecasts, because that way we can optimize both warehousing and manufacturing. Unfortunately, we cannot just simply start using AI, and throw it at any problem we may have with promo campaigns. Over 80% of manufacturers in this industry rely on expert knowledge as they develop their promo calendars. That is, they either rely on the preferences of their partners, retailers, or they rely on the acumen of their expert employees, who are mostly using Excel spreadsheets. It is pretty difficult in a situation like this to ensure proper process governance. But if you've done that, you can focus on the promo management and promo optimization. Let me contrast it to TPM. Actually, TPM is where it all should start. Thanks to such digital products, you can actually start the management process, but also you can collect the artifacts you will need later for promo optimization. If you have data of reliable quality over about 2 years, you can proceed to the next stage, which is TPO. TPO, in its turn, helps businesses rather than simply control promos. It helps businesses determine best scenarios for sales maximization. You can actually fix several variables such as volume on deal or ROI and so on and so forth. You can actually build it all into your model. And this model will continue to learn and it will adapt to the changing environment. It is clearly understood by everybody that COVID has upended the market. What led us to start using this tool? There are, in fact, two key factors at work here. One is that we actually had a TPM solution and we had a data set on promos. Also, we had quite successful experience working with our partner, a company called Rubbles. Together with them, we're able to develop an effective demand planning model that made our forecast better. And we decided we could take this success further. And we decided to start optimizing our promos. And I'm handing it over to Alexander, my colleague, who can actually tell you more about how we implemented it. Alexander? Yes, Misha. Let's consider the key components of such a solution. Well, first is the forecasting model. And a model like this will enable us to predict how effective recommendations based on this model are going to be. Also, business rules and constraints for the optimization model. And finally, the optimization algorithm itself. However, let's look at them in this specific order. Let's start with the forecasting model. Everybody knows that ML is about data. So obviously, in order to get going, we need to have at least a bare minimum of such data. So the critical minimum of data will include, for example, historical sales, historical prices, historical promo calendar, a reference list on clients and products or SKUs. Usually, we prefer to work with the data that is at least 2 years long. The way our machine learning works is that we first need to create objects that the model will train on. In our case, these are SKUs, clients, and promo periods. During the period of the promo, a particular SKU is being promoted in the stores of a particular client. Next, we populate the attributes such as product description, promo mechanics, promo sales, client descriptions, and other attributes we can mine from our data. Next, the model will look for correlations. Well, for example, our target function may be the demand function, and we will use the same attributes to describe the objects that we want to predict or forecast in the future, and then the model will identify some correlations and will predict values of the target function in the future. We are using a Python-based ML model. It's actually a light GBM, gradient boosting model, and we're using Spark in order to manage big chunks of data. So we have the model in place. However, next thing we need to do is to check if the model is indeed good quality. And some companies will actually use MAPE in order to identify how erroneous the model is. However, MAPE is pretty bad because it doesn't properly differentiate between high-selling and low-selling goods. So let's look at WAPE and bias instead. WAPE shows the breadth of distribution of our forecast, while bias shows whether we have a tendency to err on the negative or the positive side. So MAE and MSE help us predict median and average or mean sales. Obviously, they don't have to be the same. So in order for the model to be optimized, we need to optimize both of these metrics together. This is it about the predictive model. Let's look at the next element, that is optimization KPIs. These are actually the parameters that the model is going to look at as it is looking for the best way to draft promo calendars. Listed in the right are the constraints on the model, because we want to make sure that recommendations of the model are aligned with what the business needs and the business's strategy. Importantly, our objectives should not be too linear. I mean, we may want to increase, say, some critical KPIs and maybe increase our margin, maybe increase our revenue, but at the same time, shrinkage will prefer to stay low. We are using here a genetic algorithm. What's special about it is that this is the algorithm that actually tries to model what happens in real life as biological species evolve. However, instead of biological species, here we have our promo calendars. So the first thing we do is to actually generate a bunch of promo calendars using the set of constraints we decided upon previously, and then we select the best calendars using our predictive model. After that, we take out of this population, out of this universe of successful promo calendars, we will try to evolve even better calendars by cross-pollination, shall I say. So there will be mutations. We can take, for example, elements from several successful calendars, or we can try averaging calendars that are equally successful. There is another possible mutation. Rather, mutations are another possible route of change. For example, the actual content of a promo calendar can be swapped around, or we can play with other mechanics such as discounts. As we create this new population on the basis of what we consider to be, the best calendars for stage 2, we actually complete this cycle again. That is, we select the best calendars out of the new universe. And we keep doing it, we keep iterating until we develop a population, a universe of the most effective promo calendars. This is where we can actually call it a day. We can score them again using our model, and we can select the winning calendar or a set of winning calendars, which we will then submit to business units for their approval. The expected outcome of such optimization model is the increase in efficiency of promo activities, but also optimization of the work of the marketing and sales department, because we have automated the promo calendar evolution process, and also we will have the promo scenario, which meets the needs of Mars and our clients. I do hope that next year we will be able to tell you more about results of our successful implementations. And I guess this is it for now, and we're happy to take your questions.